Alright, time for another draftphysics.com and debatephysics.com. Also, video presentation. So another short video. This one's the lever argument. And it's rather a simple argument that levers have to conserve momentum. Every tool essentially has to conserve momentum. And in conserving momentum, the incidental consequences is that you have to create free kinetic energy. That objects will gain energy when you convert from an object that's heavy into an object that's light. If you convert the momentum, you'll end up with extra kinetic energy. So this is sort of a parallel to a 5-ton train going 10 miles an hour versus a 10-ton train going 5, and whether or not they have the same energy, because their kinetic energy theory basically says that no, the 5-10 equals a 25. But anyway, so the simple argument is you can't exchange by just hitting things. You can't take something going a speeding bullet and hit it into some big rock and have the energy go from the bullet into the rock. Newton's cradles don't work with different masses. But levers provide a conversion device, because you can send energy in, at a slow velocity, with a big mass and a small v. And you can basically convert it into a small mass and a big v, because you can basically connect the acceleration and deceleration rates. So as I push this object in, it decelerates, at a certain rate, and this one will accelerate. Very proportional, because it's going to move twice the distance. So every movement here, there's twice the movement on this side over here, and therefore the accelerations are matched. The deceleration of the two mass will match the twice as fast acceleration of the one mass, and you'll conserve the momentum and the lever works. That's what a lever does, is the argument. And their argument is that somehow the lever fails to do this, and somehow this object won't leave with twice the velocity, even though momentum works perfectly and it matches because the accelerations are matched. They contend it doesn't work. And yet they don't have any evidence. They've never done any lever experiments. So even though levers are thousands of years old, they don't have any recording of what happens when you push energy in and push energy out. So anyway, their theory basically says that if I just reverse this experiment, so if I do the experiment this way, I end up creating 2x the ke, which is all free. All right, it's free energy. I go in with 1 ke, I come out with 2. And if I reverse the experiment, it gets even worse, in the sense that I am basically creating 4 times the energy. This energy, this free energy, the 2 ke comes in, and I can, if I put if I put just the twice the mass, a 10 mass here, 5 mass here, 10 mass here, they will, yes, say it'll go twice the speed, but I mean half the speed. Sorry. But the fact is, they're saying that what I could really do is lift a 20 mass at 5. So a 5-ton train going 10 miles an hour in their kinetic energy theory book equals a 20-ton train going 5, which is just nonsensical, really. I mean, the one mass going twice the velocity is not going to give a 4 mass half the velocity. Not going to happen. But momentum will work, in the sense that this will be twice the motion as this, so the velocity will be half if this mass is a 2. It can't be a 4. Alright, 10-ton trains going 5 miles an hour equal 5-ton trains going 10 is the real argument. And momentum works. Ke fails this simple test. It fails to conserve the momentum if you conserve the kinetic energy. So if you don't make free energy, you have to destroy momentum. And I don't think they're ever going to show momentum being destroyed. So they're out of luck. And such.